Our goal, as we've been working on simplifying roots, is to be able to simplify the kind of expressions that we get as solutions when we use the root properties to solve power equations. When we solve power equations, we often get solutions that have very specific forms. So let's work through this example. We want to solve 6x minus 12 to the fourth power equals 162. We notice that this is an even power, so we need to use the even root property. We'll say 6x minus 12 is plus or minus the fourth root of 162. Now the fourth root of 162 we can take off to the side and simplify. Right? Going through possible perfect fourth powers, we see that this is the fourth root of 81 times the fourth root of 2. And we can actually do fourth root of 81. That's 3. And then we keep the fourth root of 2. And when I write this, I notice when I wrote that, it's really hard to tell that 4 is the index and not an exponent. Make sure that your index stays really close to your radical and like kind of in the crook, so you can tell that that's an index of the radical, not an exponent attached to the number. Okay, so we have 6x minus 12 is plus or minus 3 times the fourth root of 2. We'll add 12 to both sides and get 6x equals 12 plus or minus 3 times the fourth root of 2. Dividing both sides by 6, we get x equals 12 plus or minus 3 times the fourth root of 2, all over 6. And remember, that's actually two solutions. X equals 12 plus 3 times the fourth root of 2 over 6. X equals 12 minus 3 times the fourth root of 2 over 6. But it feels like we should be able to simplify that further. It feels like we should be able to cancel out like a 3 at least. How can we do that? How can we simplify this? If we have an expression in a form that looks like this, so a number plus a number times a root over another number, we say that that's simplified if, so the denominator is rationalized. There are no radicals in the denominator. The radical expression here is fully simplified, and the numbers that are outside of roots, so the numbers we actually have no factors common to all three of them. If we have factors common to all three of our numbers, we simplify like we would a rational expression. So what do we mean by that? Here we notice that 12, 3, and 6 all have the number 3 as a common factor. In the numerator then, I'm going to cancel out a 3, and I'll be left with 4 plus or minus the fourth root of 2. In the denominator, I'm also going to factor out a 3, right? That's 3 times 2. The 3's cancel, and I'm left with 4 plus or minus the fourth root of 2 all over 2. And remember that that's actually two numbers. 4 plus the fourth root of 2 over 2, 4 minus the fourth root of 2 over 2. And throwing all of these into the calculator, we see that we really do get the exact same numbers from these two expressions. Notice we can't cancel this 2 with just this 4. Right? We can't cancel factors that only appear in one term. We also can't cancel this factor that shows up inside the radical, because 2 is not a factor of the numerator. The fourth root of 2, which is a different number, is a factor of the numerator. Okay, let's see another example where we just do the whole thing. We're going to solve the equation, and then we're going to simplify. So we have 3 times 2x minus 6 all squared plus 14 equals 230. So we want to first isolate our radical expression. We'll subtract 14 from both sides. And then we'll divide both sides by 3. Now, we notice that our exponent is even, so we need to use the even root property. And we'll get 2x minus 6 is plus or minus the square root 72. Now, the square root of 72, going through and dividing by perfect squares, we find that 72 is 36 times 2. So we'll have the square root of 36 times the square root of 2 is 6 times the square root of 2. So we have 2x minus 6 equals positive or negative 6 root 2. Now we finish solving for x. We'll add 6 to both sides, and we'll get 2x equals 6 plus or minus 6 root 2. And notice that we can't combine those. Right, so thinking of just the plus version for a moment, 6 plus 6 times the square root of 2, that's not 12 times the square root of 2. It's not just 12. We just can't combine those. What we can do now is divide both sides by 2. So we'll have x equals 6 plus or minus 6 root 2 over 2. And then we can notice that 6 is a common factor in the numerator. X equals 6 times 1 plus or minus the square root of 2 all over 2. And now we can notice that 2 goes into 6. We'll have x equals 3 times 1 plus or minus root 2. No fractions anymore, that's great. X equals 3 plus or minus 3 root 2. Either of these forms is okay. I would tend to use this one. Right, the version without parentheses is probably better, depending on where we're going next.